Today we're gonna discuss about machine learning. So under 10 minutes, are you excited to learn machine learning? Let's get started. Okay. So here we're gonna see overview of machine learning. So what we do in machine learning, there are majorly three steps. If we go deep down in machine learning, there will be a lot of steps, but there are three major steps. Let's see one by one. So first one is data pre-processing. So here we collect the data, and we will remove the outliers, noises, and we will make the data in a perfect way. For example, let me try something. So we consider a hypothesis. Okay, this is hypothesis testing. Again, don't worry about the probability, because here we're gonna learn everything about the probability. Okay, so if you consider this is an hypothesis, okay, here we find a certain point here. Okay, so if you consider here, uh, this is a 90% accuracy of data we will get. Okay, so here anything beyond this line and this line, we will reject the data, because we don't accept this data when the data is on a middle, so it is very accurate. Okay, so this is in like in max we call if this side is positively screwed, yeah, means positive values, and this is we will call it a negative values. Okay, so we want to find the data in between these two lines. Okay, so when the data is in between these two lines, we have a 90% accuracy. Okay, so for example, so we will you will get to know. Okay, one by one. So after that, we have a step one, like data pre-processing. What we do in this data pre-processing, so we will import the data. Okay, the data may be dot csv file. Okay, c is we file. Sorry about my writing. Okay, I didn't have pen, so I'm doing it on the notepad. Okay, so we have a csv file, there may be a mp4 format. Okay, there is an mp4, which means like a video or different kinds, or maybe the combination of both uh, text data and some photos and the video data. So here we will import the data. So after that we will clean the data. So as I said you before, like if we consider a hypothesis, so here our job is to find a mean, median, mode. Depending on the situation, we will choose what we need. Okay, so here we need to find a common point. We need to find the exact value in between. There should be a value is there. So later on, when we going deep down to other courses, you will get to know what how you can find that exact point. So for example, if you consider in machine learning way, so it should be like this. If you have some, if you plot it in a graphical format, so as I said, this is the line, right? So when the point is here, here, sorry about that, here, 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 or it could be like anywhere. Okay, it's been like a different way here, here. So what we do, we will consider only the points which are near to the line. If for example, if I say there's point over here, you have to neglect or you need to remove this noise. Okay, we call the noise, we call outliers, because uh, this one data, for example, yeah, this is one data will disturb all the accuracy of the algorithm and the data. For example, if we consider in a classroom, there is a one bad boy who always sit at the last bench. Okay, he used to disturb the people who are in front benches and the middle benches. Okay, so where if you teach something, if he disturb the class, no, the order of the content delivery should be could be less accuracy. So there should be like outliers. Okay, we need to remove this data, so we will filter the data. That is called cleaning of data. After that, what we do, we will split the data. For example, a company gives us like For example, like like 10 million records of a customer, whether he buy ATM card, sorry, whether he take the ATM code or not, they will give some data. Okay, based on that 10 million records, we will split the data. Usually data we will split like 80-20 ratio. Okay, um, 80-20 ratio, 80:2 ratio. Okay, 80% of data we will give it to like test. Okay, and the 20% of data we will give it to train. Okay, after that, after the splitting of the data from train to test set, then you will have a scaling, which means by getting, like when you're trying in some machine learning, when you try to learn, when you try to do some like algorithms like regression, multiple regression. So there are different types of techniques are there. Okay, sometimes in test set you will get accuracy of 90%. Okay, and in the same test when you train the data, okay, you will get a 90%, and when you test the data you will get only, like for example 5%, sorry, 50%. Okay, so what you will do, by getting the analysis, you have to do feature scaling, means see whether the data is related, is there any differences. If there isn't differences, as I said, there are outliers over here. Okay, let me remove everything over here, then you will understand what I'm saying. Okay, so it's not going. Okay, let me create a one more sheet for you guys. So I'm new to the PowerPoint. I think it took like, yeah. So for example, let me clear this thing. Okay, come on. Okay, for example, as I said you before, this is an hypothesis where you find a line. Okay, um, near of the lines we will consider, and there may be different types of outliers. Okay, so we will consider only this point. Okay, when you train the data, okay, when you're training, sometimes you will get a 90% accuracy. Okay, so then when you test the data, okay, you will get only like a 50%. Okay, like a 50%. Then you need to then you need to, not a forecast, then you need to see what's going wrong. Is there any outliers in my data, or do I need another like algorithm? So it comes under feature scaling. So after the getting results, then you will evaluate if the data is correct or not, whether it is accurate or not. Okay, after the train and test, you can give somewhat different data in order to test your strength of the algorithm. So okay, so after after the step one, after data pre-processing. Okay, so what we have next, we have the modeling. So as I said you before, after splitting data, you model them. Okay, on next coming example we will show you an example like multiple linear regression, whatever regression. So you will build a model, then you will train the model. As I said you before, like we build a model, we find exact a middle, we will find the medium, mean, medium, mode, don't worry about it. Okay, we will find exactly center line. So when the data is near the line, it is more accurate. Okay, the outliers must be there somewhere. Okay, we will remove those noises. So here we will build this, model. Okay, for example, it could be like, yeah, text. It could be like multiple linear regression. Okay, regression models. like regression model. We have like multiple regression, uh, simple linear regression. There are like some types of regression, so it depends upon what regression you choose, what type of the data. Okay, so here after what happened if you build the model after training, what happened, yeah, after the training, oh, come on, yeah, after the train model, make predictions. Predictions is nothing but like you divide the data and you will see whether the data is accurate or not, like how much accuracy you will get. Actually you will learn on next slide example. So after you make predictions like whether this model is good or not, so after train and test set, the when you divide the data into like a 8 is to 2 ratio, whether it may be 9 is to 2, but majorly the people will take like 2 is to 2 ratio, like 80% of data will be there on train data. After the 2% is there on the test data. Okay, after training the model, you will make predictions. You will see how much is the accuracy, like 90%. I'm getting 90%. Am I getting 90%? Is 90% is enough or not? If you want to improve more, like more accuracy, there are some other like you need to go deep down into the data and you will look into it. Okay, then make predictions. If you get like 90%, yeah, it is a good data. So after that, what happened? Calculate the performance metrics. Here I can say that I told you that like 90%, or you will think that whether I need to use like another modeling technique in order to improve the accuracy. The more accuracy you make, for example, if you see if you take a data like 80%, generally, like if your accuracy would be like a 90%, which means the data would be a little bit further to the line. Okay, if you get for example, like I told you, like 90%, if you get like 90, in some cases we will use to find like 95%, which means the data would be too close to the line, which is more accurate. um, Let me choose another color. Okay, so this 95% is data is more accurate than this 90% of data. So in your whole point of view, in your whole machine learning journey, you try to improve the accuracy. That's what are the prediction of metrics. Calculate the performance and predictions and make verdict. So let's consider an example. Okay, I took this example in ChatGPT. You can also find same code. So what will happen here? Okay, first of all I import the libraries here. After that, I load the data set. As I said before, first we need to load the data set. Data equal to load. So here we give for example, if you're taking in any CSV file or any format like MP4 or whatever it may be the format, here in this bracket you will mention the extensions. Okay, for example, like the file name dot like it's uh, like sales dot csv, that you will get to know more when you going deep down. Okay, so here you will load the data. Then after that, what I said, after the loading the data, you need to segregate the data, which means you need to divide the data. Okay, here we will divide the data. Okay, after what happened, so when you get x-axis and y-axis, you will get to know more about these things. Okay, don't worry about don't go deep onto it. Okay, by going on further session, you will know how to divide the data, how to segregate data. So after that, sampling data, like you took like 80%, 20% like that. So you will do like train data and test data. Okay, this would be like 80% of the data. Okay, sorry, I don't have like notepad. So like a pen, so I'm doing it on by the mouse. Okay, so the data would be like 10% target data. So what you will do, so after you will load the data, like if you load the data, you have to segregate the data. So train and test. Okay, so train is nothing but having 80% of data, and test would be have like a, oh sorry, I'm bad at math. Don't worry. So like 80% and 20%. Okay, so the train data would be 80% and the test data would be 20%. So after that you will build a model. Here I'm using like wait a minute, I will remove this line. So here we are using initializing and training the logistic regression model. So here I taken a logistic regression because depending on the data we will take different types of regression. Okay, for example, if you choose like data science course, okay, data science course, then there would be like data types. Okay, the categorical, continuous, and yeah, throughout the course you will learn different types of data. Okay, depending upon the type of data we will take models. Like here we take logistic regression, and here we build the model. Okay, and we fit the model, which means after the training we will give that data, our data, to the model. Okay, to the model to predict the accuracy. Okay, to predict the accuracy after the model. Okay, so after what happened, after the predictions, after everything is done, okay, we will check the accuracy here. So how much I got accuracy? Like 0.95, which means 95%. Here in probability, always remember that. Okay, in probability, always remember that 1 means 100%. Okay, if something like 0 point here, yeah, here itself we will take 0.5%, means 95% of the data. Here is the 100%, so here is 90%. There may be 5% of chances that may or may not the algorithm is success. Okay, in probability we have, there is no like in everything we can ensure that there is no 100% probability. Okay, so there should be like outliers, there should be made chances. Like you can see that like no one can tell you like 100% of chances someone will that, someone will say 99% of uh, accuracy. For example, like if you a future machine learners, if you try in the data, you won't get 100%. Okay, there must be outliers, there must be certain data points will try to reduce your accuracy. So there is only 99% of chance. Okay, so this is what are the all about like machine learning. Thank you, and subscribe to my channel, guys.